So this assignment looks at more complex word problems. Some of them just have one unknown, and the reason why they're harder is because the translating from English into algebra is harder. That just comes with practice, and so we can answer questions that you have about those in class. I do want to touch on two specific types of problems that are in the assignment for today. And both of these are ones that have more than one unknown. So we haven't really looked at those this year. The first involves consecutive integers, or even integers, odd integers, but consecutive means one right after another, in a row. So if I say 3, the next consecutive integer is 4. If I say 5, it's 6, and so on. So clearly, they're just one right after another. Here's a problem that would be like that. Find 2 consecutive integers whose sum is 89. So clearly, we're talking about 2 consecutive integers, so there's more than one unknown. When there's more than one unknown, we need to write each of them down in words. In this case, the 2 consecutive integers could be called the first and the second. Because when we're solving equations, we can really, at this point in algebra, we've only been using one variable. So we can't call one of them x and one of them y. We can only call one of them by a variable. And so I'm going to say, let's call the first one x. Any other unknowns need to be represented in terms of the variable, which is just fancy talk for use x to describe the other unknown. In this case, as we've pointed out, you get to the next consecutive integer by adding 1. 3 plus 1 gives me 4. 3 and 4 are consecutive integers. So if I call the first one x, the second one is 1 more than that, or x plus 1. Now I take that information and I create an equation out of it. It says the sum of the two integers is 89. So we're going to say 2x plus 1 is equal to 89. We go and we solve that. We find out 2x is 88, which means that x is 44. Here's one of the reasons, especially this is pretty obvious and basic, but I always have to use this key so that when I get my answer, I can understand what the solution to the problem is. If I go back, I often say to kids, what did you find? Well, we found x. No, in terms of the problem, what did you find? We said we were going to have x represent the first consecutive integer. Therefore, x, when we found x, that's what we found in the problem. The first integer is 44. And we find the second one, using our key, we know we're going to add 1 to that, and we get 44 and 45. Now, it's quite similar. We might be talking about consecutive even integers or consecutive odd integers. If I start with the even integer 2, the next consecutive integer is 4, and the one after that is 6. Clearly, even integers are 2 apart. So if I call the first one x, the second will be x plus 2. And if there were a third in here, it would be x plus 4. These are consecutive even integers, but actually, if you think of consecutive odd integers, you would be starting with an odd number, say 3. The next odd number is 5. The one after that is 7. So the same way of assigning variables and variable expressions works for even or odd. Now let's do a problem, an example. The sum of 3 consecutive integers is 36. What are the integers? So of course the question is asking for more than one thing, more than one unknown. We have more than one unknown. So we're going to go back to our whole idea of writing them down. We already know how to do this because we just did it on the last page first. The next consecutive even integer would be 2 more than that. And the third would be 2 more than that. Their sum is 36. When we solve that, we find out 3x is 10. So 3x is 30, so x is 10. That means the first integer is 10, the next is 12, and the one after that is 14. Now notice we could have written this out as x plus 2 plus x plus 4 equals 36, but this is a little bit more compact, and it works just as well. Still get the same answer. Okay, another example of problems that have two unknowns comes in the form of perimeter problems. Perimeter of a rectangle. So if I say the length of a rectangle is 2 more than the width, find the dimensions. If the perimeter is 20 inches. So we are asked to find the dimensions. Notice that is plural. There are 2 dimensions in a rectangle. They are length and width. One little trick that works almost all the time is when deciding which of 2 unknowns the variable should be representing. It's a good idea to look at the sentence or phrase in which they are compared. So the 2 unknowns are length and width. Here's this place where they're compared. The length of a rectangle is 2 more than the width. Almost always, the easiest way that follows the language, the English language, when we're translating, is to have the one that's mentioned last when they're compared be represented by the variable, and then represent the other in terms of the variable. There are a few situations in which this is not true. Sometimes, especially with fractions, it's not always the easiest, but this is where you should always look to begin. If you have 2 unknowns in a word problem, look at where they're compared, call the last one mentioned x, and then represent the other in terms of x. In this case, the length is 2 more than the width. So if I start with the width, I can add 2 to get to the length. Now, perimeter has a special thing to remember that beginning algebra students often forget. That is that perimeter has 2 lengths and 2 widths. Often kids, once they've assigned the variables, will just say, well, x plus 2 will equal 20. You can see if we draw a picture why that's not true. We are calling the width x and the length x plus 2. So we need all of these things in our equation. We need x, if we're going around the figure, x plus 2 plus x plus 2, all have to add up to 20. That gives me 4x plus 4 is 20. I finish solving and I get 4x is 16, so x is 4. meaning the width is 4 and the length is 6. Notice I could just use this formula and plug in my information. 20 is the perimeter equals 2 times the length plus 2 times the width. Whatever works best for you is just fine. And I think that's all we have to worry about today.